Now, because the unit circle has so much symmetry, we can actually either use our calculator to find some values, or once we know a few values, we could actually use a graph to find the values. So first of all, let's just use our calculator. So I'd like to use my calculator to find the values of the following. I want to round all answers to 4 decimal places. That'll be pretty standard with our trig, that we'll round to 4 decimal places. Remember, in order to find these values in your calculator, you need to make sure that your mode is set so that you're in degrees. So the first thing you might want to do is go to your calculator, check your mode, and make sure that degrees are selected. So if I do these values, I actually did this out: sine of 40, cosine 40, sine 140, cosine 220, sine 320. And I noticed something. I noticed that no matter which of these values I happen to do, I get either 0.6428 or 0.7600, positive or negative. And that's kind of the point that I want to make, is I want to go, all the sines seem to come out to be 0.6428, either positive or negative, and all the cosines seem to come out 0.7660, either positive or negative. Well, that's really because of the symmetry on the graph. So if I look at a 40-degree angle, and I actually labeled that 0.7660 and 0.6428, notice if I go across into the second quadrant, this angle, using all the symmetries, would end up being 140 degrees from the x-axis over. And notice it would have the same y value, the second point, but it would have the opposite sign on the x value. So that's why our cosine ends up negative and our sine ends up positive, but they end up the same value because of the symmetry. If I go into the third quadrant, again, using the symmetry, this would be, let's see, 180 over to here, so that would be 220 degrees. Notice both of the points would be, or the coordinates would be, the same as these two coordinates were, but they'd both be negative. That's why when we did the cosine of 220, we managed to get the same 7660, but we were negative. And then if I went to the fourth quadrant, that would be my 320-degree angle. Notice in this particular case, the cosines would be the same, the x's are the same, but the y would be negative. The sine value would be negative, so that's why we get negative 0.6428. So I didn't really need to use my calculator to get anything other than the 40-degree angles. I could actually use symmetry to get the rest. So in general, what we actually learned is that the cosine of theta is actually going to be the same as the cosine of 360 degrees minus theta. That really is saying that, and I'm going to oversimplify, but that the cosine in the first quadrant and the fourth quadrant are the same. I actually can talk about it a little bit differently, but that's probably the simplest way to say it right now. What we learn is, as well, is the cosine of 180 minus theta and 180 plus theta is actually going to be the negative of the cosine of theta. A couple of things with the sine. The sine of theta is going to be the same as the sine of 180 minus theta, and the sine of 180 plus theta is going to be the same as the sine of 360 minus theta. That's going to be the same as the negative of sine theta. I'm going to tell you the truth, I don't remember any of these. If I need to find something that's not in the first quadrant and I know the first quadrant result, I just use the symmetry. I don't try to remember these. Because if you do, it's just going to clutter your brain and you're probably going to get a sign messed up. So really the best bet is to use the symmetry.